Example 1.3. The voltage source and two resistors are connected in parallel to the circuit. Elements connected in parallel have the same voltage. Calculate the current in each resistor and the power absorbed. Note the polarities of the resistors. They are opposite to each other. This example is about sign convention, and one of these doesn't make any physical sense. However, with our sign conventions, we're going to find that the passive behavior of the resistor will come out very clear. And you could see that by looking at the 25 ohm element, it doesn't follow the passive convention. So it has a non-passive convention. So here's what we want to do here. What we want to do here is that we want to determine the current and power of the two resistors. And we're going to do this by applying Ohm's law. Okay, so let's look at the first one. Since they're in parallel, I'm going to focus on the 50 ohm resistor first. So that means I have a 150 volt source with a 50 ohm resistor. And I know that the current is coming in like this, according to what they tell us. And I'm going to define that current as I50. So the equivalent picture that we see here is that we see that if we take our incline to represent the power supply, we could see here that this is the positive, the high, and that's the low. So this is the low, this is the high. So then if I have a charge right here, a positive charge, we know that that current is going to go from the high to the low. And this is the current of that 50 ohm. Of course, the voltage height of this thing, this guy has a height of 150 volts, since that's what the voltage source is. So this tells me here that since the current flows from high to low potential, it is passive. So I know that it's passive. So here I go. So now I'm going to calculate the current. So I know that the current is I50. That has to be the voltage source divided by the resistance of the 50 ohm. And that should be 150 volts divided by 50 ohms. So therefore, this gives me a positive current. So right away, we calculate this thing fairly simple. Now, if I look at the power is of the 50 ohm. And so that should be the voltage source times the current of the 50 ohm, which will then give me positive 150 times positive 3, which then gives me positive 450 watts for the power. As expected, the fact that we have a positive sign right here, that means that it's passive. And that means it absorbs energy from the circuit. Now, that is opposite of what happens with the 25 ohm resistor. So now let's go look at the 25 ohm resistor. Now, if I focus on the 25 ohm resistor, here's what I see here. I see that I have a 150 volt source. And I now have a 25 ohm resistor, but they're telling us that the current is flowing in which direction? It's flowing in that direction. And that is the current of the 25 ohm. So what this tells us here, so if I look at this thing in a physical picture, I have an incline. And here's my low. And here's my high. So that means here is that this charge is doing what? It's flowing up, right? It's flowing in the opposite direction. So this immediately tells me that when I'm looking at the height of this guy, which is 150 volts, that's going from low. So therefore, what you're seeing here is that this acts actively. This acts active. So therefore, the current, so if I look at the current, there has to be a negative sign for the current of the 25 ohm resistor. So here we go. So now what I'm going to do here is that I'm going to calculate the current and power. So if I look at the current of the 25 ohm resistor, we already defined that there must be a negative sign here. So there's that negative sign. So now I have my source divided by the resistor. So if I put in my numbers, I'm going to get 150 divided by 25 ohms with my negative sign. That gives me negative 6 amps. And that's going to be the current of the 25 ohm resistor. Now, because of the power, so now if I look at the power, we could see here is that the power, it's behaving actively. So I have to automatically put a minus sign here. But you could see that there's going to be a double minus sign, one from the current and one for the active element. So you're seeing here is that I get a minus sign here for the 150 volts times another minus sign here for the current, which is 6. So therefore, I get positive 900 watts for the 25 ohm resistor. So what you're seeing here is that, again, look, if I look at this, that plus sign tells me it's passive. So even though the 25 ohm resistor did not follow the passive convention, it is passive as expected.